What's up, internet? It's been a while since my last video. I know I'm inconsistent with my schedule, but you know, PhD. And also for this video, I've been kind of thinking a lot on one of the things we found from the literature search on the distrust in science, that is, as part of the distrust in science, at least comes from the uncertainty of the scientific knowledge. Like, I think it's okay to crave, I think it's part of being human to crave certainty, or at least to crave some control over your lives. So, you know, uncertainty in knowledge is kind of a red flag because it means that you can't really predict what's going to go on. You can't really have a way of ensuring that you're going to survive. This is the great tragedy of being human, is that we never have the complete certainty about anything in our lives, really. And I've been trying to figure out a way to explain this clear and well. So I don't know if I'm going to succeed in doing that, and if you can tell me if at least I made some headway on that, that would be a really great feedback here. First off, I would want to give you a disclaimer that the way I define things in this video is my way of defining things. If it happens to coincide with someone else, great. If you can give me the source below, that would be great. I didn't really have time to research into if anybody else talked about this in the exact same way. But you know, I know this idea has been floating around quite a bit as well, in the scientific community at least. This topic kind of ties into what we think the truth is, what we think a fact is, and what do we do to find the truth, and how do we deal with all the facts as well. And when we say truth, I think we actually mean two things. First, we mean facts, as in like how tall you are, how much do you weigh, how much did you eat today, what kind of food did you eat, what's your email address, what's your home address, what's the town that you live in. So those are facts. Those are things that people can check, people can look at. But there's also another part to truth, and that is the explanation for the fact that had happened. I don't think we disagree much in terms of what the facts are, usually. What we tend to disagree upon is the explanation for the facts that we found. And that's because we come to the explanation usually not just with the fact that's in front of us, but also the fact that we have stored in our lives, like basically from the day of our birth. We start trying to explain things to ourselves, even if we are not conscious that we're doing it. So those explanations that you have in your head are not actually truth. I think of those explanations as models. So it incorporates the facts that you've known, that things that people tell you, things you learn in school, but those are not necessarily how the world or the universe works. It's how it works according to what you know. So according to that kind of thinking, actually nobody at all know what the truth is. Now the question is, if all everybody ever has is a model, how do we know which one do we trust? If we actually have a way of accessing what the truth looks like, then yeah, then we can make a clear judgment on which model actually is the correct one. Unfortunately, we never do. Like, we only ever have access to a part of it. Even when, you know, you use the scientific method to do it, what you have is the measurement data. That's only the part of the universe. That's only the part of the law that you're trying to reproduce. So that's like, we never know really what the actual truth actually looks like. If we can't tell by looking at a certain model whether that is a good model, then how do we figure out if it's reliable enough to, you know, help us prevent a premature death? Well, actually, as it turns out, there's one thing you can look at beside from the model that may help you decide whether a model is good enough for the purpose of keeping you alive. And that is to look at the way the model is actually created. So I cannot speak for all the ways each of the disciplines actually use to create their own models. Like, you know, there's a music theory, that's the model of how music works. In economics, there's a model of demand and supply and how human exchange goods that builds up into how our economy is supposed to work. So in science, how we see it is that we actually deal with model in two different stages. So first, we have the data, in which allows us to infer a model. So that's the induction part. That's the part where you use fact to kind of try to find an explanation for the facts. But then you also have another part where you verify the model. So that's when you perform experiments so that you poke and prod at your model to see whether this is holding up with what reality is supposed to be. So when people talk about scientific model, I think it's this kind of verification process. So they kind of skip the part that they said, well, you already infer some kind of law, that is your hypothesis, and then you use the experiment to actually get data to try to verify the law. At least to me, that sounds like an attempt to put the model up against the truth and see if it holds or not. Now, that is not to say that if you have that framework in place, every knowledge that comes out of that would always be reliable. It's always subject to a kind of bias. Of course, the bias of the person who performed the experiment, who comes up with the law, like what did they see, what are the facts that they have brought with them, what are the ideas they have brought with them. There's also the bias in the sense that sometimes we don't value the inference and the verification with the same weight because we value the publication as novel. That's not something that anyone has ever done before. But then if we value that a little too much and not do proper verification, you can kind of see that the reliability is going to go down. And that's why I think scrutinizing how science is done is actually really important, because what we only ever have is a model, and what we only ever know is how we have made that model. We have to make sure that our method actually have put those models up to task. And as for anybody who have listened to what I said and just go, aha, so science is just giving us a model then, and infer that that means that science is not a reliable method. My question to you is, then what do you think is a reliable method? Like, how do you come up with your model? I think that not only should we scrutinize how science comes up with their model, we should also scrutinize how we all come up with our model, especially now that the model that is guiding our action is actually affecting everybody else on the planet. We probably really need to check that the way we used to create a model in our head is actually reliable enough that we don't hurt each other. I'll leave you with that today. Bye.